Students, today we are going to start our third chapter, matrices. So let us discuss what is a matrix. Here we have written few numbers in the form of rectangular array. In the first case, we have written the numbers in the form of two horizontal lines that are called rows and three vertical lines that are called columns. And the second one, we have written the numbers in the form of three horizontal and three vertical lines, that is in the form of three rows and three columns. So we can say that matrix is a rectangular array of numbers, or it may be functions also, which are enclosed by a pair of brackets. In general, if a matrix is having m horizontal lines, that is m rows, and n columns, then it is called a matrix of order mn. And the total number of elements will be mn in this matrix. The element at, suppose, is lying at first row and second column, at the intersection of first row and second column, then that is represented by A12. The first subscript shows the row in which the element is lying, and the second subscript shows the column in which it is lying. Like A to N. A to N means this is lying in the second row and nth column. A to 2 means it is lying in second row and second column. In short, we can write a matrix of order m by n as A is equal to Aij, and we can put here m cross n, which shows the order of the matrix. Now, the types of matrices. We have so many types of matrices: row matrix, column matrix, square matrix, zero matrix, diagonal matrix, scalar matrix, identity matrix, and symmetric matrices. So let us discuss them one by one. First of all, row matrix. Row matrix, as the name suggests, that it is having only single row. The column may be any number of column it may have. So it is a 1 by n matrix. So the elements will be A1, 1, A1, 2, and like this. So we can write A1 simply, A2, AN, because we know that it is having one row only. Column matrix means it is having only one column. The row may be any number of rows. So if a matrix is having m rows and one column, then it is called a matrix of order m cross 1. So it may be represented as A1, A2, and so on up to AM, because it is having only one column. Now, square matrices. Square matrices means if a matrix is having same number of rows and column, then it is called a square matrix. That is, when m equal to n, it becomes a square matrix. When m equal to n, we can say simply that this matrix A is of order n. Instead of saying n cross n, we simply say it is a matrix of order n. Suppose it is having two rows and two columns, we can say that it is a matrix of order 2, 2 by 2. Or if it is having a matrix, the square, if the square matrix is having three rows and three columns, we can say that it is a matrix of order 3. In a square matrix, the elements at A11, A22 and ANN position, they are called the diagonal elements. Now zero matrix. Zero matrix means if all the elements of a matrix is zero, then it is called a zero matrix. सारे एलिमेंट्स अगर जीरो हैं तो उसे हम जीरो मैट्रिक्स कहेंगे. Then we have diagonal matrix. Diagonal matrix means जिसके नॉन डायगोनल एलिमेंट्स सब जीरो हों. That is a matrix in which Aij is equal to 0 for I not equal to j. और तो जितने भी नॉन डायगोनल स्क्वायर मैट्रिक्स जिसमें नॉन डायगोनल एलिमेंट सारे जीरो हों तो वो हमारी डायगोनल मैट्रिक्स कहलाएगी. जैसे हमने यहाँ एक मैट्रिक्स लिखी है जिसमें केवल ये हमारे नॉन डायगोनल एलिमेंट्स नॉन ज़ीरो हैं. डायगोनल एलिमेंट्स नॉन ज़ीरो हैं, बाकी सब एलिमेंट्स ज़ीरो हैं. So it is an example of a diagonal matrix. So it is a square matrix whose non-diagonal elements they are zero. Scalar matrix. A diagonal matrix is a scalar matrix. Means a scalar matrix is a special case of diagonal matrix in which all the diagonal elements they are equal. अगर diagonal elements same हैं तो that diagonal matrix becomes a scalar matrix. जैसे इसमें हमारे diagonal elements -1 है, यहाँ हमने diagonal elements √3 लिए हैं. So it is a scalar matrix. Then identity matrix. Identity matrix scalar matrix का स्पेशल केस है जिसमें जो diagonal elements हैं वो सब 1 हो. तो if A11, A122 up to ANN equal to 1, then that scalar matrix becomes the identity matrix. Like here we have written a identity matrix of order 2 because it is having 2 rows, 2 columns and all the diagonal elements are equal to 1. Similarly here it is a diagonal identity matrix of order 3. It is having 3 rows and 3 columns. So it is an identity matrix of order 3. It has the property that when you multiply it with any matrix, the result will be the same matrix. That's all for today. Thank you.